Welcome students in this audio PPT National Science Day 2026. National Science Day is celebrated every year on 28th February. This year's theme is Women in Science Catalyzing Viksit Bharat. Why Science Day is celebrated? National Science Day was declared by Government of India in 86 and first National Science Day was celebrated in 1987. It is celebrated on 28th February every year to commemorate discovery of Raman effect by Bharat Ratna Dr. C.V. Raman. He discovered scattering of light by molecules. This changes the wavelength of the incident light. In the scattered light, two new lines were discovered by him, one of short wavelength and another of large wavelength. These lines were named Stokes and anti-Stokes lines. Theme of the year 2026 of National Science Day is Women in Science Catalyzing Viksit Bharat. National Science Day's main central subject is participation of women in science as a catalyst for Viksit Bharat. Other aim of National Science Day are to spread science among people, to show the importance of science in our lives, to make students aware about the importance of science so that more students study science, to motivate girls and women to participate in scientific development so that Bharat become self-reliant. This presentation is in three parts. First is life and work of Bharat Ratna C.V. Raman. Second is Indian woman in science. And third one is discovery, invention and innovation. Part 1, Life of Raman. Dr. C.V. Raman was born on 7th November 1888 in Tiruchirappalli in Tamil Nadu. His father was Sri R. Chandrasekhar Iyer, lecturer of science and mathematics. His mother was Srimati Parvati Ammal. He completed MA and joined the post of accountant. Later on, he joined Indian Association for Cultivation of Science established by Mahendra Lal Sarkar, and after some time left the job of accountant. One day, his colleague Dr. K. Krishnan told him that Compton got Nobel Prize for X-ray scattering by electrons. Then he at once replied, if X-rays are scattered, why not ordinary light? He started working in that direction. In 1928, he declared that light is scattered by molecules and we get new lines using a simple spectroscope worth rupees 500 at that time. In 1930, he got Nobel Prize for his discovery. He not only discovered Raman effect, but so many other discoveries also, including blue color of sky, musical instruments, tabla and tanpura, how the sounds are produced by these instruments, fluorescent stones, crystals, gems, etc. At present, cost of Raman spectroscope ranges from 2 lakh to 1.5 crores. This is the experimental arrangement by C.V. Raman at that time. This is source of light. This is a filter. Here the material under study is placed Outside it, water is circulated to cool it in the perpendicular direction. From here, the filter monochromatic beam is incident on it, and in the perpendicular direction by this spectroscope, he observed the lines which are scattered. This was the spectroscope used by C.V. Raman. This picture shows molecular scattering. A laser beam is shown here incident on a molecule. This molecule vibrates and rotates. This rotational and vibration of the molecule due to the incident laser beam creates three lines. One, the central one is the original line, and this is Stokes-Raman spec line of wavelength greater than the incident beam, and this line is the uh, scattered beam of wavelength less than the incident laser beam. Raman lines have been explained on the basis of quantum theory of light. A photon is incident on the molecule and excited to higher energy level. When after some time it comes to the ground level, it emits that photon. Here in the first case, the emitted photon is of same frequency as the incident beam. This is called Rayleigh scattering. In this situation, when a beam is incident and a photon h nu 0 is absorbed by the molecule, and after some time the molecule does not come to the original state, instead up to some higher state. So a photon of lesser frequency than the incident beam is scattered. This line is known as Stokes line. In the third case, we get anti-Stokes line when incident photon has less energy and the emitted or scattered photon has greater energy. Some energy is imparted by the molecule. This slide shows uses of Raman scattering. Raman scattering is crucial for identifying chemical compounds and understanding their molecular structures. In pharmaceuticals, Raman scattering is used in quality control process. In material science, this technique is used to analyze the composition and structural properties of materials. In biomedical applications, Raman spectroscopy is used in medical diagnostics to non-invasively detect diseases. In environmental monitoring, Raman scattering facilitates the detection of pollutants in the environment. In forensic science, Raman scattering is useful for examining crime scene evidence. So, based on the uses of Raman effect, we see that it is important in so many fields. Now, Raman effect is used to detect structure of nanomaterial, DNA, protein, and molecules. And at present, laser Raman spectroscopy is used to characterize a large number of solid, liquid, and gas materials. Part 2, Indian Women in Science. In India, nearly 25% women are in science and engineering fields. Department of Science and Technology DST has launched various programs to promote participation of women in science. Under this scheme, Wise Kiran, that is Women in Science and Engineering, Kiran, the programs are Wise Fellow for doing PhD, Wise PDF, Postdoctoral Fellow, Vidushi for senior scientists working in the society, Wise Scoop, Vigyan Jyoti, and Gati. These are other programs. Some prominent Indian women scientists are Janki Ammal, a renowned botanist who specialized in cytogenetics and phytogeography, notably developing new higher yielding sugarcane varieties. Due to her work, India became self reliant in the field of sugar production. Asima Chatterjee, a chemist known for her work on medicinal chemistry, specifically developing drugs for epilepsy and malaria. Casey Thomas, known as the Missile Woman of India, she was the project director for Agni 4 and 5 missiles. Ritu Kridhal Srivastav, a space scientist at ISRO, who played a crucial role in Chandrayaan 3 and Mars orbiter mission, that is Mangalyaan. Dr. Kamal Ranadive, a pioneer in tissue culture and cancer. These are some Indian women in science. Cytogenetist Dr. Archana Sharma, botanist Janki Ammal, biochemist Darshan Ranganathan, chemist Asima Chatterjee, physician Kadambini Ganguly, anthropologist Iravati Karve, materialist Anna Mani, engineer Rajeshwari Chatterjee, mathematician Raman Parimal, physicist Biba Chaudhary, pathologist Kamal Ranadive. Now, third part of this presentation is innovation. What is innovation? Innovation is turning any invention or discovery into a useful work. Innovation is not in invention, it is to add an creative idea to it so that it becomes valuable. Now, what is the difference among the terms discovery, invention, and innovation. Discovery, as the name suggests, to uncover anything or natural law that pre-exist. For example, Newton's law, electromagnetic induction, electron discovery, proton discovery, X-ray, etc. Invention. Invention is to make or create something new. For example, electric motor, bulb, aeroplane, computer, artificial intelligence, mobile phone, pen, thermometer, etc. Innovation is to modify any discovery, invention, product, process, service, or combining technologies so that it fulfills our purpose. For example, driverless car, smartphone, chat GPT, digital thermometer, etc. Innovation is a 5 to 7 step process. Here I described a 7 step process. Step 1 is identify opportunities or the problem. Step 2, generate ideas to meet that problem. Step 3 is evaluate and select ideas. Step 4, develop a prototype. Step 5, test and iterate. Step 6, implement and scale. And step 7, monitor and evaluate. Innovation examples: biomass energy, burn organic waste to produce electricity; waste from waste, such as dhupbatti and other products from flowers offered to God; decorative items using waste materials; using wearable detectors for diseases, such as electronic device for glucose monitoring. Innovation areas in rural area: Soil Sathi, a portable device for rapid soil and water nutrient testing, aiding customized fertilization. Saptakrishi, a low-cost IoT-enabled device that significantly extends the shelf life of perishable produce. Drone-based farming, mechanization, renewable energy utilities such as solar-powered cold storage, inverter bulb, portable solar panels. In the field of healthcare and technology access, telehealth, connecting rural small hospitals to urban specialists, digitalization, AI-powered personalized rural insurance, and digital tools for connecting with global markets. Renewable energy grid, sustainable agriculture, road development, government initiatives in the field of innovation. National Innovation Foundation, under this entries are open till March 2027 from innovators, which are unaided innovations. MOE Innovation Portal, under which establishment of IIC, that is Institute Innovation Council, organizing college hackathons, regional meet, and then national competition, IP literacy, entrepreneurship, startups. These are covered. Other initiatives are Nidhi, Prayas, etc. By the continuous efforts by the um, government and people, India rose to 39th rank in 2024 from 81st rank in 2015 in Global Innovation Index. These are some figures for students to show different type of innovative works. A rectangular wheel, triangle, smart cap, solar tree, solar cell on barren land. This is one use of barren land which is not or cannot be used for other purpose. Thank you for your attention and watching this presentation. Please tell how you like this presentation. Thank you.